This video's got a few questions about translators. So a translator could be an interpreter or a compiler, or we could use an assembler to translate. Or we could use an assembler to translate assembly language into machine code. So the first thing to think about with the idea of translation, before we start thinking about the questions, is that the computer uses binary. So binary instructions are the only thing the computer can read. So we sometimes refer to those binary instructions as machine code. Machine code. So we've got this here. The image below shows two levels of language. Now identify the levels of language. So machine code, this is machine code because it's binary numbers. That's the lowest possible level of language. So that's low level. So it's the lowest possible level is machine code because that is what the processor actually reads. So it's the closest to the processor language possible. So that's the lowest level. So this language is a high level language. So it's some variable assignments and some adding together of variables. So this is a high level language. So it could be any language, could be Python, could be C, C Sharp, C++, any Java, any of those languages are high level languages. So that's a high level language. So that means it's furthest removed from what the processor can read. So when using the language on the left above, so the high level language, what is the relationship between an instruction the programmer writes and what is executed in the processor? Well, one to many is the relationship, because one instruction in the high level language can equal lots of instructions in the low level language. So just making the variable x equal to 12, just that one line of code could be several instructions in machine code. So it's one to many in that case. So another type of language is called assembly language. So assembly language, you might see this sort of thing. So we might say LDR R100 assembly language. It stands for load register 1 with whatever we find at the memory location 100. So that's a memory location. Whatever we find there, we're going to put into register R1 in the processor. So that's assembly language. You need to recognize assembly language, but you don't have to be able to write it for GCSE. You don't need to be able to write programs in it. So what's the relationship here? Well, this is directly loading a register. So the clue is the idea there. So it's 1 to 1. So one instruction in assembly language is the same as one instruction in machine code. So we're directly manipulating the registers. We are getting something from memory and putting it into the processor, rather than just generally assigning a value to a variable like we are in high level language.
And this question just suggesting two reasons why a programmer might decide to write in assembly language instead of machine code. So machine code being like this, so just binary numbers, binary commands, and assembly language being something like this. So we've got things like load register R1 with whatever's at memory address 1000, and move into register R2 the value 20, and add both R1 and R2 together and put the result in R0. So the essential reasons for this is that assembler is much easier for humans to read. So assembly language is a lot easier to read. So we'll just write that in. It's easier for humans to read, and as a result of that, we could program it much more quickly. So humans make less mistakes using assembly language than machine code. So it's much more likely to make a mistake here in machine code if we're trying to remember and trying to write down long strings of ones and zeros. It's really easy to get one in the wrong place, and then it's really hard to find those errors as well. So really difficult to find errors in machine code, whereas it's a bit easier to find those in assembly language. So we can label things as well in assembly language. So if we're doing loops and things like that, we can loop to a label, and that makes it much easier for humans to visualize that as well. So the best really answers is it's easier for humans to read, and so we could say therefore we could program it more quickly. Humans make less mistakes to read when they're using assembly language than machine code. So it's much easier, which I can't write. We'll try again. Much easier to write code more quickly and easier to remember instructions. So any of these things are good answers. It's obviously much easier to remember these kind of instructions because we can kind of semi-read what they mean than it is to remember what one of these is. We'd really have to look up machine code instructions. So that's the best answers. So 2 reasons why I might use assembly language instead of machine code.
So then the next question, what type of translator is used to convert assembly language into machine code? That's an assembler. So just be careful when you're writing that. Don't write down assembly. That's in the question there. Assembly language is an assembler that assembles the assembly language into machine code. And then we've got a more tricky question, perhaps a longer question. This is the sort of thing that might be on GCSE as a longer answer question. Explain the operation of an interpreter and a compiler when translating a program file to enable it to run. So enabling a program to run means that we're going to need to put it into something that the processor can read, and that's ultimately binary. So there's 2 ways we can do that we need to think about on the question. The first one, an interpreter. So an interpreter is the sort of thing you use if you are using maybe REPL or PyCharm or something like that. When you press like the run button, that's going to use an interpreter to interpret your code that you've written. And so interpreters, they run line by line. So they take one line of your code and they look at that and interpret it into something that the processor can understand. So they use built-in routines to operate the processor. So they've got built-in machine code operations that they use. So we're not creating, so they don't directly create machine code. So they don't create any machine code themselves, but they use their own built-in routines to run whatever it is that you want to run on your program. They use those to run on the processor. So the basic points for interpreter we're going to make are they run line by line, they use their built-in routines, and they don't directly create machine code. So in order to run the interpreter, software must be present. All right, so we've made 4 points. So you choose any of those points. So when we're writing this, it's likely to be a longer answer question for writing. So we can write about all of those points, and we'll definitely get our marks for what an interpreter does. So then we need our marks for compiler. So a compiler, first thing we might say is reads the whole program instead of line by line. So it reads the whole program and creates an executable machine code file. So instead of using built-in routines like the interpreter, the compiler is creating an actual executable machine code file. So because of that, you don't need the compiler software to run the program. So you don't need your development environment. So if you've written a program and made an executable out of it, you don't need your software like Visual Studio or whatever it is you wrote it in order to run it. So it can run independently of that now. So the 3 things that we've got basically there: reads the whole program, actually creates an executable file, and you don't need that software in that case then to run it. So, there are other things we could say if we were asked the question about advantages or disadvantages. So, executables are often faster to run than interpreted files. But this particular question, if we go back and look at it, it's just explain the operation of an interpreter and a compiler. So we've explained the operation. So the other thing compilers can do is can create an intermediate file called bytecode for further translation by a virtual machine. So that might be something like Java, where you might create some Java bytecode and then be able to translate that using a virtual machine. So that's the other thing a compiler can do. So that one's kind of a bit of higher end knowledge, I suppose. So if we got the 3 things, we'd be fine. That one there is another thing that compiler can do. So we've probably got our 6 marks. So I wouldn't necessarily write those things like I've done in bullet points. I've just done that so it's easier for you to see. but you might write a little bit of prose for this, because it might be one of the marks might be there for having a coherent argument or a coherent set of writing. The other thing it's looking for is the correct use of terminology. So the idea of machine code, the idea of creating machine code, the idea of built-in routines, the line-by-line execution or running, the needing to have the interpreter present. Those kind of things are the sort of language they're looking for. So creates an executable machine code file. You don't need the compiler software, bytecode, technical language, that kind of technical language they like to see in that kind of question. So that's more of a tricky one, the longer answer question, but the sort of thing you can sort of learn really, I guess, is what 3 or 4 things does an interpreter do? What 3 or 4 things does a compiler do?